working. Okay. This is called a sequence. In mathematics, mathematicians call this a sequence. Are you guys taking notes over there? Alex and Dan, you guys with me? Mason, you with me? You have something to write with? Okay. So this is called a sequence. A sequence in mathematics is just a list of numbers. That's all it is. A list of numbers. That's a Q. Sorry. Sequence. A list of numbers. Sequence is a list, that's a colon, of numbers. If that list has a pattern to it, where you do something to 7 to get 10, and then you follow that pattern to get the next number and the next number and the next number. So in other words, there's some predictability to it. We call that recursive. A recursive sequence. If you Google the word recursive, it might make sense why we call it a recursive sequence. Lillian. It's when you have a sequence with a pattern to it. Because technically, 1, 3, -5, 7, 14, 1,000, 1,000,000, -7.5, that is a sequence, it's a list of numbers, but I just made those numbers up with no pattern whatsoever. So if you have a pattern, it's a recursive sequence.
So a pattern is a recursive, right?
A recursive sequence has a pattern.
Oh.
Yeah, a recursive sequence has a pattern. Good clarifying question, West. Really good clarifying question. West asked, well, yeah.
Well, yeah.
Yeah. I think, well, yeah. I was going to repeat it for the folks at home, but I think my answer on the board is sufficient. Okay. So what we've done here is I've stripped away all the context. I'm just going to build some linear skills today with this list of numbers that has a pattern. The first thing we do is we want to identify the growth, identify the pattern, so that we know how to extend it and we can say some things about it. For example, I know this is linear with a growth, also known as slope, also known as a constant rate of change of +3. Alex, I found it interesting, your comment. You wanted to make 7 the 0th term, and your comment was because it just makes sense. Can you defend that comment, please? Like, why in your brain does it just make sense?
Because, okay, if you think about it, right, a table is just a graph, but I guess in the simpler form, I can't really explain it, but they're practically the same thing. And graphs, usually both their axes start at 0 because you're working with the 4-quadrant graph. So it starts at 0, 0. So a table should also start at 0 because if they're the same thing, then they should start at the same number. I mean, unless you're dealing with a really specific case. But.
So what I hear you saying, if I can repeat your order back to me, let me know if I'm getting it right. What I hear you saying is that because we know that we're ultimately going to create a visual for this called a graph, and we know that with graphs like that, equations come next, and we have this thing that it's always going to cross an axis somewhere. Unless we're told that the 7 has some implication for being the first of something, then why not use 0? So unless you have context that makes sense to assign term number 1 to 7, why not use 0? Is that kind of what you're saying?
Yeah, like if you take an example like with the cup thing that we were working with, that would start at the first term because obviously 0 cups would be 0 centimeters tall.
Right. Yeah, so with that context, it makes sense to assign numbers, but as it stands right now, maybe just throw 0 on there. Okay, Maddie?
What I was gonna say was similar, like if you're planning on making an equation with it, it makes sense to start with 0 because you need 0 for the table. And if you don't, you're just gonna have to go back and later and do math, and it's easy, it's 4, but it might be more complicated.
Yeah.
It's adding an extra step.
Yeah, it is adding an extra step. Wes, go ahead.
So I was just gonna ask what we should title.
What do you want to title this?
Yeah.
I don't know yet. Let's wait till the end. We'll give it a title at the end. So, I'm just going to offer a different perspective. It's not more correct. I think what you both are saying, and if anybody agrees with that, it makes perfect sense. Just a different perspective is it's the first number we're presented with. So call it the first term. But I am going to show both. Options. So we have 2 different opportunities here. In the red, we're going to go with Alex and Maddie. We're going to start at 0. Oh God, 22? Yeah. Is that how you guys, Emma and Tyler, got 22? So you just added 3 to the next number?
Yeah.
But you weren't thinking like 10th term. You were just like, oh, next term's
And
22.
35 actually
Yeah.
added 4 to another one. So.
You added 4 instead of 3? Got it. I would. Yeah.
Can we make the graph like the actual, or not the graph, the table in a different way?
Yeah, I was just going to do that because that green is kind of terrible, isn't it? Thanks for pointing that out, though, because I don't always catch that stuff.
That's
And-
not what I was saying.
Oh, is that not what you were saying?
No, I was saying like how we usually make tables. Like yeah.
Oh, you can do whatever you want in your notes. Yep. If you want to make your table vertical, that's totally fine. And then the other option is like, well, the first term is 7 because that's the first number I was given. So Maddie said something that I'm gonna repeat, and that's that I think Maddie said this. If I choose to do this second option in the black table, the thing is I have an extra step because at some point I am going to want to know the y-intercept. So I'm going to have to, once I find the growth, and Lillian actually stepped us through this also. She said I subtracted 3 and got 4 to figure out what the term that came before. So you just have that extra step of finding the 0th term is 4 if you think about it this way. I'm going to do a quick sketch just for our notes. This is not precise. But I want to highlight the biggest difference between these 2 graphs. And that would be that the black graph would have a y-intercept of 4 and a growth of 3. And the red graph would have a y-intercept of 7, so it would be parallel, but it would be sitting on top. They would have the same growth, the same steepness of the lines. It's just one is below the other because of the y-intercept. Now our notes from yesterday. M is the growth. B tells me where the y-intercept is. Remember that y equals mx plus b is what form? What's this called? It's also called slope. Slope form, slope. What form is it called? Slope intercept form? Slope intercept form! There are lots of equations of lines. This one is a form of an equation where we see the slope and we see the intercept. You have these notes from yesterday. So my intercept on the red graph is 7 and my slope is 3. So it's y equals 3x plus 7. But over here, the equation would be 3x plus 4. But I have not defined my variables. What is x and what is y? What does x represent?
The term number.
Yeah, that's super important. X represents the term number and y represents the term. One of my favorite mistakes when I talk or I introduce linear relationships in Math C is here, I'm going to draw something. I repeat, I'm going to draw something in blue. I'm going to draw something in blue. Do not copy this into your notes. I'm going to draw something in blue. Do not copy this into your notes, okay? One of my favorite mistakes is that students will so often, and some of you did this on the quiz last night, they see this growth and they go, oh, 7 plus 3 is 10. 10 plus 3 is 13. 13 plus, so it's x plus 3 is the equation. Maybe they go like that. This is wrong if x is the term number and y is the term. Because if x is the term number, what's 4 plus 3? Is it 19? Do you follow what I'm saying? Am I talking too fast? Okay. It's hard to know sometimes. You can totally like interrupt me. If I say x plus 3, this person is thinking recursively. They're thinking about how to get from one y to the next. But when we use x and y, we're actually trying to figure out how do I go from the x to the y, the x to the y, the x to the y. There is an equation for recursive this, but I'm not teaching it to you this year. I'd have to teach you a whole new notation, and we're not doing it. Lillian.
Wait, I just wanted to ask, would the either of the equations, would it be right if it was either 7 or 4? Or
Are you asking if both of these equations are correct? Yes, they are both correct. But Lillian, I will add this caveat. If you wrote the red table and the black equation, that would be incorrect.
they aren't using both tables,
Correct. So what Abby is saying is that both equations, the equations don't fit both tables. It's like either or. It's like you think about it the way Alex and Maddie thought about it, and you get the red table and the red equation, or you think of it as term 1 is 7, term 2 is 10, and you get the black table and the black equation. You're thinking about it in an either or way. And to be perfectly honest, there are infinitely many answers, because maybe Abby comes along and goes, I'm going to be a rebel, dork, and says like 7 is the third term. And then comes up with a completely different table and equation, but she would also be right as long as she said to me, 7's the third term, man. Don't go being a rebel, okay? Not yet. You got a broken ankle. You need to like nurse that first and then